So in this video, we're going to see a data structures 2 marks question from the year GATE 2015, and it's based on the topic of max heap. So let's read what the question is. The question says, consider a max heap represented by the array so forth. So we already have a certain max heap into given as a question, and it is represented by an array. Now consider that a value 35 is inserted into this heap. So we'll insert a new value 35 into our heap, and now after insertion the new heap is. So what will the new heap look like? So before we go ahead, let's quickly see two important properties of max heap. The first important property of max heap is that the parent of a max heap will always have a greater value than its two child. Okay, that's why it's called as a max heap. In min heap, it's opposite. The parent will have a less value than both of its children. In max heap, since we have only max heap into the consideration, the parent value is going to be greater than or equal to both its children. This is the first property. And the second important property is that the nodes in a max heap are always inserted into a level order. Okay, so the first level is completed, only then the second level is completed, and after the second level is completed, we go for the third level. So the insertion of nodes in a max heap is always in a level order way. So these two are very important properties of a max heap. And now when we construct a new max heap, we have to ensure that these two properties are always satisfied. Okay, so first of all, let's go ahead and let's draw the structure of our input original max heap. So okay, let's go up. So this is the starting point 40, then I have 30 and 20 as it's. So as we know, it's a level order. The array which represents max heap, it's a level order representation of a max heap. So all the nodes are in their level order way. Next is 10 and 15. So 10 and 15 come here. Next is 16 and 17. So 16 comes here and 17 comes here. And lastly, we have 8 and 4. So we have 8 here and 4 here. Okay. So this is the input max heap which was there. And now what they have done is they have considered that value 35 is inserted into this heap. So new value 35 is going to be inserted into the leaf. So again, we have to follow this property. Okay, we have to follow this property that the nodes are always inserted in a level wise. So the new node will be inserted here, 35. So 35 gets inserted here. Now after the new node is inserted, we have to ensure that property number 1 is satisfied, that every parent in the entire max heap, not just the root, not just this root, but every parent has a greater value than its child. So here, as we can clearly see, let's zoom in a bit. Yes. So here, as we can clearly see, this parent is having a less value than its child. So whenever there is a mismatch, the operation that we perform in max heap is called as bubble in. It's called bubble up. So what happens is we just swap the values of the parent and the child. So this value becomes 35 and this value becomes 15. Okay, now after we do this bubble up operation, we keep on checking for the parents which are in above level, that whether the property is satisfied or not. So here, as we can see, now 30 is the parent and 35 is the child, and the value of parent is not greater than the child. So again, whenever there is a mismatch, you just do bubble up. So 35 goes up here and 30 comes down. They just swap with each other. Now 40 becomes a parent here of the new child 35. So again, we have to check the property. Yes, the property is satisfied here. 40 is definitely greater than 35. So that's it. Now our heap is in a stable structure. Now what we're going to do is we're going to write a level order traversal of this heap. So you can see 40 is at level 1. Then we have 35 and 20 at level 2. Then here, okay, here at level, so this was level 2. Here at level 3 we have 10, 30, 16 and 17. And finally at level 4 we have 8, 4 and 15. Yes. So this becomes my level order traversal of the new heap after inserting the node 35. Now this has to match with one of the options. So let's see. Okay, so 40, 30, 20, this is incorrect. We want 40, 35, 20. So this is not there. 40, 35, 20, okay. 40, 35, 20, okay. So C also goes out of competition. B and C are the probable candidates. Next we have 10, 30, 16. 10 30 16. Okay, 17 18 4, 17 8 4, sorry 8 4, and then lastly 15, lastly 15. So B matches with our new level of reversal, so B is our right option.